नए पुराने हो गए सर।
Sir, our physics question paper. Physics, chemistry, biology are like mixed together.
It is mixed
Sir,
together.
very easy paper. Very easy paper. Sir, let's see your marks.
Very easy.
Here it's physics. Here chemistry and biology.
So
Sir,
here,
see the numerical. The numerical was easy. She was the easiest one. 3.2 the answer. Newton.
you're finding it easy because I taught you. And you listened to me. Where is your paper?
Sir, it's on.
Acha, it's different school. You're not in the same school? Okay. How many of you have written tests in your schools of the topic we have taught? Just one school. मिला marks मिल गया?
नहीं सर, कल ही तो दिए.
तो पेपर के बाद में प्रैक्टिस कर रहे हैं ये पहले कर लिया था अभी और एक टेस्ट होने वाला है ठीक है so we are meeting after a gap of 2 weeks so where did we stop in the last class huh? Laws of motion okay where in laws of motion
So the test was for ABS laws of motion.
acha and have I taught you that okay so I praise myself for the topic I have taught and listen maths give me physics where did we stop last class
Third law.
Inertia.
Third law.
so I have taught that right third law of motion that means she was absent
Heat वाला सिखाओ ना.
कौन सा
Heat chapter.
क्यों
ये खत्म.
ये खत्म ही नहीं हुआ
इसके बाद.
पहले
उसके बाद एक
थर्ड लॉ क्या करना है स्टार्ट करना है खत्म करना है
खत्म हो गया ग्रेविटेशन.
अच्छा ग्रेविटेशन
वो मोमेंट है ना कौन सा ग्रेविटी और डी और
थर्ड लॉ के हमने एग्जांपल्स डिस्कस किए थे वॉकिंग एग्जांपल्स ऑफ ठीक है
और केमिस्ट्री भी चलो लगता है she gives good marks but
यस ये किसका Okay, let us start with examples of so are you following Shubhanshu Shukla's
yes
Space Odyssey?
yes sir
Who is that? That's a good question. Then you're not following the space mission.
He follows car accidents.
So he becomes the first Indian astronaut okay, to reach the International Space Station. Who was the first one?
Rakesh Sharma.
That was when? 40 years ago. Okay, when your father was a kid. The first astronaut from India was Captain Rakesh Sharma.
He's still alive.
Yes, very much.
I know.
So you were fact giving the International Space Station.
Who?
The one with the big thing.
Who?
Very disconnected. Shubman Gill is a cricketer. They are saying Shubhanshu Shukla. Okay. So the reason is the Newton's third law is applicable in making Shubhanshu Shukla reach space. How?
So what about Sunita Williams?
Launch same. She is not Indian. She is Indian origin, but American national.
NRI.
No, she is not NRI. She is an American citizen. She doesn't hold our country's passport.
POI. Person of
Indian origin.
And
Yes, POI. So, launch of rocket. Where is Newton's third law of motion at work? Launch of rocket.
rocket launcher.
So, when the rocket is launched, what happens? Smoke. So, when the fuel inside the rocket is burned, right? When smoke comes out, comes out of rocket. So the force which is applied on the smoke by rocket is action. This then applies reaction, upthrust. Okay, this is action. Okay, so in Newton's third law, you have to identify the action and reaction forces. So the force with which the smoke comes out, okay, that is the force applied by rocket on smoke. Therefore, the smoke applies upthrust on rocket. Because of that, the rocket lifts up. Okay, so this is the Newton's third law at work. It happens simultaneously all the time. The force with which the smoke comes out, same force keeps on increasing. As it lifts up, the smoke comes out with large and large force.
So one the rockets in Isaac Newton's time.
Was the
Were the rockets in Isaac Newton's time?
So it is like this. When he conceptualized all these laws, okay, those laws were applied later on. That's the job of technologists. There are two people, scientists and engineers. The job is different. So scientists tells you the possibilities. Yes, this is possible. Then there is a team which starts working on it. They are the team of engineers. Like the principle on which the car operates, maybe it is using all Newton's laws, but Newton did not make this. Okay, who made the car? The team of technologists. These are different areas. Technology comes in the application area. And what Newton did is knowledge production. These are two different things. Okay, so that's why you have application level question that falls in the application of the laws. That's different. But there are people with lot of vision and foresight who think about possibilities that yes, this is possible. So they are called scientists. Okay. Now, and both have different careers. Then walking.
Gun.
Okay, recoil of gun. How is Newton's third law applicable here? So when gun fires bullet, so there may be some arrangement here we don't know. So when gun fires bullet, when the trigger is pulled, okay, so it will go and hit the bullet, and the bullet will leave the gun. So VB is the velocity with which the bullet comes out, and VG is the recoil velocity of gun. Okay, understood? So what is action? The force on bullet. VB is velocity. What is action? Force on bullet. Action is force on bullet. Force on gun. Are both forces equal? Yes. The bullet travels in such a large degree. So don't miss the concept. You went too far. Okay. Concept is action and reaction. By action and reaction. So what is action here? Force on the bullet by gun. And reaction is force on gun by bullet. Then the third application could be walking. How is Newton's third law involved in help us walk? Is action and reaction in case of gun identified? Everybody comfortable in case of gun? What is recoil? Recoil means whenever you fire a gun, okay? So gun recoils back. Okay, always it is like that's why if it is the rifle butt is held inside the arm.
Sometimes like rocket launcher.
Not here. That is above.
Rocket launcher.
Above.
That I'm saying.
Above. Because if you keep it here, it will break the bone of the shoulder. Or dislocate it. It may dislocate it. Because of the reaction, it may dislocate it. So it is either held here, so that like a spring action, or it is kept above. So it will go behind.
Only
Okay?
because like rocket launcher the only capture.
Now we don't like only when the troops are in field, then only. Otherwise they have a stand, tripod stand. So it's a fixed stand on which it is.
Those are different guns.
Oh, machine guns, light machine guns.
Snipers and LFGs.
There are rocket launcher, portable rocket launcher which can be carried on.
Sniper.
Sniper is different.
Sniper में कितने का grounded.
Sniper is long range gun. You can shoot the enemy from say 500 meters, a kilometer, even 3
So have
kilometers.
you used the guns?
Yes.
Sir, किस
I was in NCC, National Cadet Corps. I was studying in Kendriya Vidyalaya. My father was in Air Force.
So what job did you have before joining the Navy?
I was in a corporate. I traveled the world. This is my hobby to teach. Don't you get it? Okay. So I used 303. That was a small gun, very small. Like in 8th or 9th standard.
I have used an
You have seen, your dad also in army? So anybody interested in seeing guns, you can visit the Navy Day. Have you been to Navy Day? So just follow Navy Day celebrations. It's open to public. Ask your father to take you there. And it's open to public. So there everything will be on display.
Even on in Tech Fest, they also give guns.
Tech Fest for IIT.
Yeah,
So you have to follow those things now. Okay?
there was gun.
Future is very bright for India. Lots of money is being allocated for research. 1 lakh crores is just allocated. Around $16 billion or something. Just calculate how much is that. Okay. So much of backing is given by government for this. Now let us understand Newton's third law at work in case of walking. So when you're walking, what do you do when you're walking?
We push.
How do you walk? Yeah, you push the earth. Okay?
Maybe.
But are we able to push the earth?
No.
No.
Earth pushes.
Earth is too big,
Oh, yeah.
right? Earth will react. So basically,
For
when we are
example,
trying
that
to,
hamster wheel, when we walk like in that hamster wheel.
Who works in a hamster wheel? You should work in a human wheel.
Yes, that only, bro.
Human wheel.
so when you are pushing, okay,
I actually. It's very good.
so push on earth by foot, okay, that is action. So that is action. Push on foot by earth. So push on foot by earth is reaction. So it is a reaction by earth enables us to walk. Okay? And then the friction lets us not slip.
Sir, how much spark plugs broke?
Irrelevant right now. First pay attention here. Okay? I mean I can tell you that, but in 10, not now.
First pass out.
Is that clear? How we are able to walk? So reaction from earth. So this is action, this is reaction. Like that, there are so many things. How we are able to row the boat? So when you move the oars, right, you are pushing the water behind. Yeah. When you are moving the oar of the boat, you are pushing the water behind, and then the water forces us ahead. Okay, so the reaction from the water, swimming also, similarly. So now you should be able to identify action and reaction forces in variety of situations. Okay. So I think these three examples are good enough. Next is universal law of gravitation. Okay. Let's discuss universal law of gravitation. There are so many examples given in your book. Now that you have understood this, you will be able to understand others also. What is universal law of gravitation?
Water by straight.
Okay, are you done? So this is the last law. We have done how many laws so far?
3.
3 laws, and this is the 4th law.
Never mind.
The thing that goes up comes down. Right?
Like when we throw them.
Okay. Can I explain the law?
Sir, almost done.
I added acid to my water gun.
So his leg is fractured. This is correct, right?
Oh yeah.
This is correct.
Oh, dance.
I mean, one leg here, the other was here. Now this is correct. Okay. Everybody pay attention now. So what is universal law of gravitation? Very important law. So first let us understand what is universal law of gravity. What are you doing? Stop drawing now, everybody with me.
Sir, just.
Done?
Yes, sir.
Wrote today's date? Everybody?
27. 266.
No, imagine Christmas this year comes at 99:30. How can go on the 36? It's Christmas differently.
This year's Christmas 2525. This Christmas.
Not possible.
Okay, let me explain the universal law of gravitation. What it states is, between any two body in the universe, okay, between any two bodies in the universe, separated by some distance, there exists mutual force of attraction. Okay, there exists mutual force of attraction. What does it mean? Like, both bodies attract each other. Understood? What does this law state? This law states that between any two bodies in the universe, these bodies could be anywhere in the universe, these two bodies, and if this is the distance of separation between them, both bodies will attract each other. Okay? And how much is the force? This force is given as
Two tomatoes will be each other. Tomatoes will be each other.
how is this force? This force is directly proportional to the product of the masses of the bodies and inversely proportional to the square of distance between them.
As a
How will they
statement.
attract each other?
Huh?
How will they attract each other?
Just like Earth is attracting this, is Earth not attracting this?
Because they have weight.
You both are also attracting each other. But why are you not getting mixed up?
Molecular force of
Because of the region I'll tell you just now. Okay? Because we haven't yet learned how much is the magnitude of the force. So this is the law. Law gives how much force is acting. Okay? So when you combine these two, therefore F is this is the law. The force, how much is this force? This force is equal to, now when you remove this proportionality, the force becomes this. This is the force. Between any two bodies in the universe, there exists a force of attraction which is directly proportional to the product of mass of the bodies and inversely proportional to the square of distance between them. So distance is taken between their centers. Okay, is that clear? So where what is G? Where G is called universal gravitational constant. And is equal to it is given as this is its value.
Newton meter square.
Kilogram.
Again,
Newton
this
meter
is the
square
value.
per kilogram square.
Yes. Because keep the G here, multiply D over here and M1, M2 here. So F unit is Newton. This is meter square, kg square. So G becomes Newton meter square per kg square. Understood? So just like small g is 9.8 meter per second square, capital G is this much. Okay. So let us say, so as per this law, there must be force of attraction between these two pens also, isn't it? So let us find out how much force is acting. Imagine this is 1 kg, this is also 1 kg, and they are separated by 1 meter. So let's find out how much is the force. If M2 is also 1 kg. And
There are finger tests.
okay, so when you solve it, what is the force? So what is the magnitude of force between two bodies of 1 kg each separated by 1 meter?
6.67 into 10 to the power minus.
Is it a big force or a small force?
Very
It is so small, almost zero. Huh? This is decimal followed by 10 zeros, 667. What is this number?
Wow, yeah.
Almost zero, right? क्या बेटा चीटिंग घुस गई क्या चीटिंग बिजनेस में ऐसे चला
0.00000000667. Why did you say Newton? Why did you not say Newton meters per kilogram?
So this is such a small force that you don't see that the body is affecting. Okay. So where is this force visible? Sun, moon, right? Now here it is visible. Earth is able to attract this body. This body is also attracting the Earth with the same force. Why is Earth not coming here?
Earth is heavier.
It is heavier because what is
Because the mass of Earth is way more. Higher the mass, higher the force of attraction.
smaller the acceleration? No, F is
Greater the mass, greater the
mass into acceleration. So therefore acceleration is F by m.
Not by you.
So if the force is same, if the force is same for constant force, so what is acceleration and mass relation? If the force is same between both the bodies, then the acceleration produced is inversely proportional to mass. So if the mass is small, then the acceleration will be more. Earth mass is so much more. So the acceleration produced in Earth will be almost zero. Right? Okay, so I'm not giving you the statement of Newton's universal law of gravitation. That statement you can read yourself. What is the statement now? Read the statement of universal law of gravitation. Everybody will read the statement of Newton's universal law of gravitation. I'll make you stand and state. So everybody read for yourself and memorize.
Now,
Now. So what is Newton's universal law of gravity? Where is your book? Where is your volume? Why have you come? Just come here to have a picnic. You're disturbing others? Where is your book? Why do you come? Hello. Hello.
Excuse me, sir.
Now you stand and take notes. What did I just tell you? Everybody has to read the law and memorize. I'll ask one of you to stand up and state the law. Huh? No, that's not the law. Yes.
Sir, sir,
Where are you?
sir, fundamental shape of the reaction क्या
You get here, not on the head. Don't act smart. Huh? When I'm teaching the concept. When I'm joking, I'm joking. When I'm serious, you got to understand when I'm serious. Don't joke all the time. Whenever I'm explaining a concept, everybody got to be focused. Doubts later. When I'm teaching, no doubts. I'll give you time to ask doubts, but not when I'm introducing the concept.
Because they have
Okay, who would like to state Newton's universal law of gravity? I will choose. तो अभी लिख लिया तूने पढ़ा लॉ पढ़ा वो बंद कर लिखना पहले लॉ पढ़ा you know utter read it for yourself open your mouth when I ask you to so where is the law all of you have volume page 46 हाँ ठीक है तो बुक में से पढ़ के बताओ लॉ हाँ कृषि चलो बताओ व्हाट इज यूनिवर्सल लॉ ऑफ ग्रेविटी क्यों लिख रहा है stop writing stand up I said stop writing stand up what's the law volume पकड़ page 46 hold the volume in your hand stand up read the law
Every object in the universe attracts each other body with a force which is directly proportional to the product of their mass and inversely proportional to the square of the distance between them.
okay so this is the law mathematically I have written it like this every body in the universe attracts every other body in the universe with a force which is directly proportional to the product of the masses and inversely proportional to the square of distance between them. This is the law written mathematically like this. So when you Now remove the proportionality. You will change it with constant, which is G. What is G called? Universal gravitational constant. Okay. Its value is determined experimentally. Sit down. Its value is determined experimentally, and it is this much: 6.67 into 10 raised to minus 11 Newton meter square per kg square. Now you will remember this value when you sit. When you sit. When you do, when you solve a lot of numericals, you'll be able to memorize these values. Okay. So then I have showed you how much actual force is acting between any two bodies of masses 1 kg each, separated by 1 meter. So this force is not visible in objects having small masses. Okay. So now this force. Now let us find out what is the force with which Earth attract any body. Okay. Consider there is Earth, and now you have an object with mass 1 kg. Let us say it is at a distance of 1 meter from Earth. वो तो कर नहीं सकते.
10 meter.
अर्थ के केस में 1 मीटर नहीं होगा, कितना होगा? रेडियस हो जाएगा. Radius of the Earth. Okay. Then mass of the Earth. What is mass of the Earth? Nearly 6 into 10 raised to 24 kg. Very big. Okay. And radius is 6.4 into 10 raised to 6 meters. It's about 6400 kilometers. That's the radius of the Earth. Imagine the object is very close, okay? Very close. So we will ignore this distance. Imagine this is very close to the surface of Earth. Like, I can have this object fall from here. It is still attracted, right? So I ignore this distance. Then what is the force now? It will be G, mass of Earth into M divided by R. R square, isn't it? Okay. Now also by Newton's second law, this body will fall with acceleration g. So F is also equal to mg. Correct? Okay. So how much is this? Okay. So how much is this? Therefore, you get G is equal to GME upon R square. If this body was 1 kg, then this also will be GME by R square. Right? Now, when you solve this, like substitute all the values, 6.67 into 10 raised to minus 11 into mass of Earth, which is 6 into 10 raised to 24 kg. Just check how much is mass of Earth given to you. Mass, how much is that? 5 point, which is nearly 6. Okay. So when you have this divided by 6.4 into 10 raised to 6 whole square. When you do this value comes to nearly 9.8 meter per second square. So what we just derived is relation between G and small g. Relation between G and G. So far we have been telling you to use the value of G as 9.8 meter per second square. How did it come? It comes from here. This is from Newton's second law. है ना? So if you have any object of mass m falling close to the surface of Earth, this force you get by universal law of gravitation, and this force you are getting by Newton's second law. Both are acting on the same object, so they must be same. When you equate this, then you are able to derive the expression for small g. Understood? So I said, when we have two objects of 1 kilogram each separated by 1 meter, right? What is the force of attraction? This, very small. But now if I take 1 kg object, okay, if this becomes 1 kg, right, then I get GME by R square. Then what is the force then? In that case, the force will be 9.8 Newton, nearly 10 Newton. Okay, so it's not zero. So this object, when it is falling, it is experiencing a force of 10 Newton, provided its mass is 1 kg. So how to feel 1 Newton? Keep 1 kg on your hand. Whatever force you are feeling is 10 Newton, 10 Newton. So if you keep 100 grams on your hand, that is 1 Newton. 1/10 of a kg is 100 grams. So what is 1 Newton force? How will you feel 1 Newton force? When you place 100 grams on your hand, that's when you are holding or you are opposing 1 Newton. Is that clear? Okay, समझ में आया? So what is 1 Newton? Suppose you are holding, is it a palm? Let us say 100 gram you are holding. So what is 100 gram?
1 Newton.
Hmm?
1 meter.
It is 0.1 kilogram. So what is the force on it? Which is nearly equal to 1 Newton. Okay, this is nearly equal to 1 Newton. Understood? So, are you getting the feeling now? Why the object falls towards Earth? Because Earth is pulling it with this much force. Now this is non-zero. Okay? So, hope you are getting. So, if you have 1 kg, that means what force you are holding? 10 Newton. Okay? So, that is the weight. That force is called weight. mg is weight, which 1 kilogram mass of object experiences. So, weight of the body is nothing but Earth's gravitational force acting on that body. What is the weight of the body? mg, which is nothing but Earth's gravitational force. This is weight. M is mass, mg is weight. So mass is a scalar quantity, whereas weight is vector. Is that clear? Alright, so we have now understood. So what is acceleration due to gravity then?
The acceleration of the falling object.
Yes. We already have covered it. It is the acceleration developed in a freely falling object towards Earth. What is acceleration due to gravity? It is the acceleration developed the freely falling object. Under the influence towards her. Okay, it is the acceleration developed in the freely falling object towards Earth. It is given as G, 9.8 meter per second. Okay, or okay, G is also used approximately as 10 meter per second square when it is mentioned in the question. When it is not mentioned in the question, you have to take it as 9.8. Default value is 9.8.
So there are 10 stages.
You are smart, right? What is the meaning of 10 raised to minus 11? So, anyone has any doubt till here? What is free fall motion? When do we say the body is falling freely? Object is falling downwards only under Earth's gravitational force. What is free fall motion? Yes, skydiving, is it a free fall motion? Till the parachute is not open. Okay, skydiving with closed parachute is free fall motion. Right? So what is free fall motion? Free fall motion. An object falls only under the influence of Earth's gravity. Is said to be free fall. So when the object falls only under Earth's gravity, it is said to be in free fall. So what are the motions possible in free fall?
Throwing an object.
Downward and upward. Both motions are in free fall only. Okay, if we toss a ball up, it goes up and comes down. Okay. Example. Ball dropped from terrace. Terrace spelling correct?
No, sir. Double
Huh?
R.
Double R and then
That's it.
terrace. Yes. So this is like only downward motion. So ball tossed up reaches tossed up or thrown up. That's right, thrown up. Reaches maximum height and then falls downward. So it has both upward and downward motion. You don't write anything. What's her name? You don't write anything. I told you in the first class also. Huh? You write only in exam. Make a habit of taking notes. Start doing that right now. I'll make you sit late and complete the notes if you don't do it. I mean, you have to be active student. Don't just watch movies. There is a reason why I'm asking you to note down. I know everything is given in the book. So ball thrown up reaches max height and then falls downward. So what kind of motions are here in this case? In the first case, there was only downward motion. What about second case? Upward as well as downward. So when you solve numericals for such kind of motion, there is a equation of motion during free fall, which is same as the equation of motion learned earlier. But now you have to replace A with G, acceleration due to gravity, and S with H, height. Okay? So what are just write down the equation of motions during free fall.
Sir, लिखा है।
तू अभी तक यहाँ कर रहा है, तो ये सब क्या? लिख नहीं रहा है भाई, तू बात कर रहा है बैठ के यहाँ पे और अब I cannot wait. You have to write. So equations of motion during free fall.
सर लिखा है।
Equation of during free fall.
पिछले चैप्टर।
लिख लिया है? That was horizontal. Free fall motion. हाँ शायद एक दो क्वेश्चन किया है.
H is equals to UT plus
Vertical motion किया है, but यहाँ पे more formally. So what are the three equations? V is equal to U plus GT. H is equal to UT plus half GT square. And V square minus U square is equal to 2GH. ये मोशन है. ठीक है? अब यहाँ पे साइन कन्वेंशन क्या है? G is positive for downward motion. And G is negative for upward motion. ठीक है? G is positive for downward motion and G is negative for upward motion. At top, U or V is 0. ठीक है? What is the meaning of the last one? At top, U और V 0 मतलब क्या? Downward motion में U 0 होगा. Don't close your notebook. Everything is to read. Everybody will show me the notebook before leaving.
Oh my God.
जो लाया है वो सब लिखा है. जब डाउनलोड मोशन शुरू कर रहे हैं टॉप से U 0 है, initially it is at rest. Next time say you must have your notebook, textbook and UT volume. 3 things. रात को बैग पैक करो. Everybody understood? No comedy when I'm introducing new concepts. Because if you miss the concept, then no doubt solving session will do justice. कोई question है? ठीक, sure. So if you have any doubt, I will clear in the next class.
ये इधर को बुक किधर है?
सर जी
Technical.
पहले मेरा